So today we've got a service call on a walk-in freezer not working. Everything in here is pretty soft. So it's probably been down for a little while. No evaporator fan motors running. We're obviously going to need to jump onto the roof. It doesn't look like there's any ice formation going on. So we'll continue this on the roof. This is a very interesting walk-in. They obviously built this around an existing structural beam for the building. It's actually in a shopping mall. Seems very interesting. Okay, so I pulled this panel off. This is my electrical section. I believe this is my freezer unit. This is the only one that's not running right now. And then, come on over here. This is a walk-in cooler. And one of the fan motors isn't running. So that's another thing we got to take care of. We'll have to get them another fan motor. So for now, we're going to jump onto this guy right here. Just from opening it up, it looks like it doesn't have power because the time clock's not lit up. I'm going to get my meter in there and we'll check it. I'm going to go ahead and check voltage. 204, 203, 203. So that's a good sign. We have three-phase voltage coming into the top of the contactor. I don't know that I necessarily see a light on the defrost clock, so the next thing we're going to do is check the defrost clock. We're just going to go across 1 and N. And we see that we have 204 volts. That's good. Now I'm going to jump over from N to 4. We have no voltage on N to 4. And then we're going to go from N to 3. We have no voltage on N to 3. Okay. So this tells me that we have a bad defrost clock. The way that this system works, power comes in on 1 and N on this clock. 208 volts comes in, powers the timer motor inside the clock. Okay? Then if you notice, this one is 1. I know it's hard to see the terminals, but trust me, this one is 1. There's a jumper. There's a little metal jumper. Sometimes you'll see a wire. That jumper is jumping over to terminal number 2. Okay? What that's doing is that's bringing one single source of power in and energizing 2 common terminals of 2 separate contacts. So 1 and 3 is its own contact. 2 and 4 is also its own contact. So what we're doing, again, we're just bringing a common terminal between the 2, so we only have to bring one source of power in. Now this defrost clock works in this way. When the pins are in, okay, that is refrigeration mode, normal operation. When the pins are out, like you see right there, there's 2 of them, that is defrost mode. When the pins are out, you will have power at your number 3 terminal. So between neutral, or the N terminal and 3, you will have 208 volts on this particular clock when it is in defrost mode. When it is in refrigeration mode, you should have power between 4 and neutral. Okay? And the way that this clock works is it will not power the other contacts when when one of them's power, basically. So when we have power to 4, we will not have power to 3, or vice versa. Okay? So again, we have got 208 volts between 1 and N. Okay, so that means that we have 208 volts going to that clock, powering the timer motor, and sitting at the common terminal of both of these relays right here. Okay? So, at any given time, one of these relays for this, when this clock is working right, has to be energized. And neither of them are energized right now. If we go between 3 and neutral, we get 0 volts. And if we go between 4 and neutral, we get 0 volts. That means that internally on this circuit board somewhere, this clock is not working properly. Now, here's a really important thing to think about. This clock likely shorted out inside of itself. It's always important to look if it was in defrost mode or if it was not in defrost mode. It's possible that the clock itself caused the problem, or it's also possible that a short in the system caused the problem here. So with that being said, if we investigate this properly, we were in refrigeration mode. So more than likely, if there is a problem somewhere else, it will only be in the refrigeration mode components. Are you get where I'm going there? Again, we don't know 100% sure, but more than likely, there's not going to be a problem in the defrost circuit or an electrical short in the defrost circuit that potentially made this clock go bad. Now again, I still need to investigate more. We don't know what happened. So the best thing to do is to go ahead and turn off power, okay? Make sure that we are de-energized. Nothing, nothing, nothing. Okay, so we de-energized this clock. So the next thing we're gonna do, you guys can't hear this, but I'm gonna put the meter to my ear and I'm testing for tone, okay? So what I'm gonna do is I'm gonna test from every terminal to ground. And we're gonna see if we get a tone. That's gonna help us to indicate if we have a direct short anywhere. There's nothing on the number 4 wire, nothing on the number 1 wire, nothing on the number 3 wire. Okay, again, I'll do it again so you guys can see here. I'm testing for tone on my, okay. That is me touching to the panel. So now I'm gonna go and touch to every terminal to ground to see if there's a potential electrical short in any of the wires. Now it's not showing up quite yet. Okay, nothing showing up yet. My fear is that I put a new defrost clock in here and it burns out the new defrost clock. So we want to check everything that we can before we go and replace this defrost clock. The next thing that I'm going to do, again, you always want to be cautious about pushing contactors in. I'm going to push that contactor in now and turn the system on to see if the compressor starts up, to see if there's anything that jumps out at me that might be a problem. By the end of the service call, I will put my service gauges on this, but at this point, I do not see a need to, okay, because I'm not diagnosing a low voltage a pressure problem at this point. Right now, it looks to be just a problem in this defrost clock. And if we look carefully, it does kind of look like there's some burn marks up here in this corner. Okay, so what we're gonna do is we're gonna energize, okay, and I'm gonna push the contactor in. You always wanna turn your face away when you push a contactor in. Okay, when I did that, the unit is running. So, more than likely, we do not have a problem with an electrical component and it's just a bad defrost clock. Okay, we wanna take this time because I'm gonna tell you guys, from my experience, I've ruined a lot of parts by just throwing them in and not diagnosing first. There's nothing worse than putting a new defrost clock in and then letting the smoke out of that new defrost clock. And then you gotta drive to a supply house to get one because of something simple. You could have tested just a couple little things, like I just did right now, just to see if there was an electrical short, okay? So in my opinion, I've done everything in my power to ensure that there's no electrical short that I can prevent that would cause this clock to go bad. So we've checked everything. So at this point, I'm gonna go down to my truck and grab a new defrost timer, go ahead and replace it, and then we'll go through the rest of the system. Okay, so I've got the clock replaced. Notice how the green light is illuminated. I think you guys can see that right there, okay? If we look at the back of the old clock, right where those little, I think those are resistors. Yeah, right where those little resistors are, it kind of looks discolored. It's actually really discolored on the back of the clock too. I don't see an actual burn mark. Sometimes if you stare long enough, you can find where the short is. Regardless, I don't need to know that quite yet. What we're gonna do is we're gonna test the clock now. Now this, just stabbed myself. These little things are sharp. They totally just stabbed me in the hand. That's crazy. Things are sharp. All right. Let's test from 1 to neutral. So I'm going to move this guy over here. You can see this a little bit better. There we go. I should say let's test to 1 to N. It's not necessarily neutral, it's N terminal. Okay, 208 volts. That's good. That means we have 208 going to the clock, to the timer motor. Okay, so now we're going to test 4 to neutral. And we have 208 volts. That means we are in refrigeration mode and everything is running. Okay, so because it's in refrigeration mode, we should not have any power going to the number 3 terminal. That would be the defrost mode. We have no voltage. That is good. So this is the proper operation of this clock, okay? The fan terminal sometimes can be used to cycle fans. You typically don't see that very much. At least in my restaurants that I deal with, you typically don't see the fan terminal being used. You do see the X terminal. That's a really big one, okay? I'm gonna try to paint this picture a little bit easier than usual. Let's assume that we have a light switch downstairs. A simple light switch like you have at your house, okay? And someone's standing inside the walk-in, and when the unit goes into defrost, if it gets too hot inside that coil, someone flips that light switch. What happens? Power runs through that light switch up to this X terminal and energizes a little relay inside here and tells this clock, hey, it's hot enough, turn off the defrost. Okay? We call that defrost termination. Okay, now, it's not as simple as someone using a light switch. There's actually a clicks-on thermostatic device inside there, and when it gets warm enough, it closes a set of contacts. Okay? We also have a device down inside that coil called a fan delay, and the fan delay has exactly what it sounds like. There's a delay when we put it into refrigeration mode. It waits until the evaporator coil gets to a certain temperature, usually about 20 degrees, before it turns on the evaporator fan motors. Okay, we do that so that way when we go into a nice warm defrost and we have all that moisture dripping off the coil, a lot of times that moisture will hang up on those aluminum fins on the evaporator coil. And if it pops out of defrost and the fan motors turn on right away, then all that moisture will get blown off of the coil and refreeze inside the box. Okay, so we have a fan delay. Now, some evaporator coil manufacturers have a separate fan delay and a separate defrost termination. And then some manufacturers actually incorporate it all into one little clicks-on that has 3 wires coming out of it. So you're just running a common wire, and then if the coil gets cold enough, it sends that common wire to the fan motor. If the coil gets too warm, it sends that common wire up to here to terminate the defrost. Okay, so that's all the terminals explained on this defrost time clock. Now, this is not the only time clock that is out there. They all work on the same principle, but sometimes the letter designations might change. That's where it comes in handy reading your schematics and understanding the evaporator coil schematic. Because sometimes the X terminal might be a common wire. Sometimes the neutral terminal or the N terminal might be a defrost termination. Who knows, okay? There's all kinds of different sequences that you can follow. I would say for the most part, the more common style is this right here, or the mechanical Paragon clock that's an 8145. It can either be a 2-0 or a 0-0 at the end of the 8145, and all that designates is a voltage, okay? That's pretty much it on this clock. One thing that I forgot to mention is the defrost duration, okay? We have a defrost clock or defrost timer, and its sole purpose is to put the unit into a defrost however many times needed a day. Okay, this particular system requires 4 defrosts per day with a fail-safe time of 30 minutes. Now, that's a very important designation there, fail-safe, okay? Most of the time, you will terminate your defrost on temperature before the fail-safe time finishes. Does that make sense? Okay, so we go into a defrost for 30 minutes a day, but that little clicks on relay that I explained to you, called the defrost termination switch inside the evaporator coil, is going to sense the temperature of the evaporator coil, and wherever it's mounted is really close to the return bins, the copper fins. Sometimes it's even mounted on the copper fins, and the manufacturer has designed the perfect spot to mount it, so that way when they get to a certain temperature in that evaporator coil, it terminates the defrost. Okay, so this particular system is temperature and or time terminated. Okay, so we can terminate the defrost by simply timing out 30 minutes and then it stops, or we can terminate it by the temperature of the surface where the clicks-on relay is mounted in the evaporator coil. Okay, now, so I went ahead and mounted, like I said, 4 30-minute defrosts, and that's pretty common here in Southern California. That's all we need for the most part. Unless we have a very problematic box, then we can increase it. Theoretically, you could increase your defrost time to 45 minutes because it's probably going to time out anyways. One thing you have to be very careful about is a lot of people do not understand defrost termination, and it confuses them. Therefore, you go out there and you find that the X terminal wire is disconnected and wire netted off. So what that person before you did was either they couldn't figure it out, or they figured it out and just didn't have time to go back and replace the defrost termination switch downstairs. So they just disconnected it and wire netted it. But when they do that, they turn this into a just simply time terminated. One thing that you will see a little bit more on a system where the defrost termination has been disconnected, you will see, not a lot, but you will see a little bit more moisture inside the box. Even though there is a fan delay, you will tend to see a little bit more moisture because it runs longer in the defrost. Typically in a walk-in freezer, the ceilings and the walls get a nice thin layer of like permafrost or you know, frost on them. And when the unit goes into a defrost, if it defrosts too long, that moisture that's been frozen to the ceiling will start to drip off. Okay? It's also moisture from when people open the doors a lot. The warm air comes right into the box, rises to the ceiling, and then freezes. Okay, so for the box to properly get rid of the moisture, it's imperative that we have our defrost termination hooked up and we don't have it set for too long of a time, and our fan delay needs to be working properly also. Okay? I went ahead and pulled the cover off the unit. I'm doing a visual inspection. I'm about to hook up the smart probes, but something I noticed is that when you shut off power, watch the motors, and the right side motor comes to a stop instead of a slow spin. That's an indication that that motor is going bad. So at this point, I've got the smart probes on, and currently they're running a clear sight glass. Good indication. So our evaporator fan motors are running, the box is coming down in temperature. It's going to take a while. I'm not going to stay here and watch the whole thing come down. Like I said, I'm coming back with some fan motors. I'm confident this will fix it for now, and then we'll change the condenser fan motor and make sure everything's good when we come back. So this is the next day now. I'm back out here. I ordered the motors and we received them. I just want to show you guys something. You can really see it here because power's turned off. Spin this one. And notice how it comes to a slow stop, okay? Spin this right one. Notice how it comes to a quick stop. Like just, the bearings are going bad. See how that one effortlessly spins to a stop. So this motor's not bad, it's just going bad. So that's why I'm replacing this one today. You can also see that it looks like this right here, the shaft, I just wiped it. It's like the oil blew out of the bearings or something, because the shaft is covered in dirt and oily substance. And you look at the other one, the shaft is nice and clean. So we're going to replace this. I'm in the process of changing this. Just want to point something out. You know, The two most common nut drivers for motors that on the motors that I work on is 11/32 and 3/8. So I keep just a sole 11/32 nut driver in here, so that way I don't have to run down to my van to get a socket set or anything like that. So if you're doing a lot of condenser fan motors, restaurant refrigeration kind of work, and 11/32 is going to be your best friend for evaporator motors, condenser motors. You're going to use it a lot. Same thing with the 3/8. So just a little tip. Condenser fan motors are running. Always want to check your amp draw. It's a pretty basic thing, but you got to remember that. 0.89. So we're under amps. We're allowed to run 1.1. And always check your time clock settings. It just so happened that I came up here. I didn't go into the freezer. I just came up here, turned the condensing unit off. It wasn't running when I got up here. Just turned it off, changed the motor, turned it back on, and there was no power. And I kind of had a little panic for a moment, like, wait, is there a problem with this box? So I checked to make sure it didn't have any blown fuses. Nope, no blown fuses. So I went downstairs, walked into the box, and I noticed that it looked like they just got a delivery, because mind you, I was here yesterday and the box was empty, and today it's packed to the ceiling. And then I asked the cook, did you guys get a delivery today? And he says, yeah. And I go, what time did it come? And he says, oh, like 6 a.m. Well, right now it's 11:15 and they never turned the breaker back on. It scared me for a minute because I just changed this time clock yesterday and I was thinking, oh man, is there still a problem with this? Mind you, it's fine, but just went down there, turned on the breaker. Now we're just gonna watch it come down to temp, and then I'm gonna change the fan motor, condenser fan motor on the walk-in cooler while I'm waiting. So obviously this is our evaporator coil. This system does not use a 3-wire fan delay defrost termination. It has 3 individual limit switches. One of the limit switches is a defrost termination, one of the limit switches is a fan delay, and one of the limit switches is a heater safety switch. So just like I said, it's just like a light switch. The fan delay is just waiting for someone to flip the light switch to say it's cold enough in here to turn the fans on. The defrost termination is waiting for someone to flip the switch saying that it's too hot in here, turn off the defrost. And then the heater safety is there as a redundant safety in case the defrost termination doesn't work. Mind you, these are thermostatically controlled devices, so the little metal disc inside reacts to temperature, but I use a light switch as a term to make it easier to understand, because theoretically that's all that it is just a temperature actuated switch, really. So once it gets cold enough, it does whatever it needs to do. Once it gets hot enough, it does whatever it needs to do, and if it gets too hot, you know, it stops working. So that's pretty much it on this. So right now this unit actually happens to be in a defrost. Mind you, if you guys look at this, do me a favor and tell me how many heaters you think this system has. And think about what a heater is. It's basically just a filament inside that tube right there. Okay, see that greenish tube with the black thing? It's just a filament inside that's getting hot. So if we have a heater, how many do we have here? We have 2 total heaters, because you have to have 2 sides to one heater, right? Power in and then neutral out. Okay, so there's 1 heater on the top, and then there's 1 heater in the drain pan. Now this thing is running in heat mode right now, or defrost mode. So if we just simply grab this, check the amp draw, we have 5.81 amps. Same thing up here, check the amp draw, 5.52 amps. So both of our heaters are working. Alright, now we have, let's add another thing to the system. We have this guy right here, which is a drain line heater. It basically is just a warmer wire that wraps around the drain line to make sure that it doesn't freeze when it's in the freeze mode. This warmer wire is typically wired in to 4 and neutral. Okay, remember 4 is our refrigeration circuit, because the theory behind that is that we don't need the drain line getting warm when it's in defrost, because it's going to be warm water dripping down the drain. We need that drain line having heat around it when it's in the freeze mode. That way if there's a problem in the drain line, it'll keep the water liquefied, so that way it doesn't freeze until it goes into defrost again. Okay, so that particular heater is wired into foreign neutral. And that's pretty much it, guys. That's just the basics of electric defrost on a walk-in freezer. This is our refrigeration side of the evaporator. We have a thermostat. We have a pump down liquid line solenoid valve, expansion valve, and a distributor, all going into the evaporator coil. And then the sensing bulb for the expansion valve is running out and being strapped to a horizontal section of the suction line where you can't see it right now, but it's in there. So let's just do a little recap. We had a service call on a walk-in freezer not working. When I arrived, evaporator fan motors were not running. This was on a shopping mall, so I had to gain access through security. Got them to let me up there. Got to the condensing unit, found that it wasn't running. The first thing I checked was 3-phase power coming into the condensing unit. We had that, 208 3-phase. Then I checked the next place, which was the time clock. I checked to make sure we had power coming in, and we did, but we had no power going out on the defrost or on the refrigeration circuit. So that to me indicated that we had a bad defrost time clock. So I went ahead and replaced that, powered up the unit, watched it run, checked the pressures, looked good. I did confirm that we had a condenser fan motor that was going bad, so I went ahead and ordered that motor. One little tip I wanted to give you, if you ever do any shopping mall work, this one has saved me some headaches. I would suggest if you don't have a company identification card, a lot of times the shopping malls, they request that you leave an ID with them while you're on the roof. Some do, some don't, but I see more that do than don't, okay? What I do is I actually use an expired driver's license. If you're anything like me, then you've probably left an ID at a shopping mall multiple times and then realized a couple days later that you didn't have your driver's license, which kind of sucks. So that's why I use an expired one. And then what I do when it comes time for renewal for your driver's license, if you have to go into the DMV, I would just say I just lost my license, and then you just keep it. Because if you hand it to them, they want to like cut it up or hole punch or whatever. Just tell them, oh, I lost my license, and then you get to keep the old one. So that's a little tip that I use, and so that way if I ever leave an ID at a shopping mall, it's an expired one and it's not my normal driver's license. That or get an identification card or have a company ID. You know, that would be the right thing to do, but I don't have company IDs. I don't really do that for my guys. So just a little tip. Okay, guys, other than that, we're good to go.